Welcome back, everybody. We're on day 17 of the series, and we're on our path to a 750 plus here and on the SAT math, and we're going to dive right in to our first problem. And today we're going to be dealing with algebra problems. Okay, an economist modeled the demand Q for a certain product as a linear function of the selling price, P. The demand was 20,000 units when the selling price was $40 per unit, and the demand was 15,000 units when the selling price was $60 per unit. Based on the model, what is the demand in units when the selling price is $55 per unit? Okay, so it tells us what we need to know here. An economist modeled the demand Q as a product of the linear function of the selling price. So Q is equal to our slope times P, which is the selling price, plus B. So P here is really our X. I'm going to rewrite this as Y equals MX plus B. So P is really our X, Q is really our Y, and we have to solve for B. So we're given 2 points here, and those 2 points are, so we have a selling price of $40 per unit here, 20,000 units, and we also have a selling price of $60 at 15,000 units. For just clarity, we're going to do this as y2, that is x2, this is y1, that as x1. And we're going to plug in for slope, and we're going to find 20,000 minus 15,000 over 40 minus 60 is going to give us 5,000 over negative 20, and then this is going to give us negative 250. So that's our slope. Now we're going to rewrite the equation. Q is equal to negative 250 times P, which is the price, plus B. And how do we solve for B? We plug in a point. And we're going to plug in 40 into 20,000 here. So we have 20,000 is equal to negative 250 times 40 plus B. And B here is going to be equal to, this is going to be 10,000 or negative 10,000. We're going to add that to that side, and this is going to be 30,000. Now we can rewrite our whole equation again as Q is equal to negative 250P plus 30,000. So it's a decreasing linear function. And it's asking what is the demand when the selling price is $55 per unit. So what is Q when P is 55? So Q is equal to negative 250 times 55 plus 30,000. And when we plug that into our calculator, we have 250 times 55. And then we subtract that from 30K, and we get an answer of 16,250, which is answer A. So we've seen a lot of these problem types in recent videos, so I'm really hoping that you really grasp the concept here of the y equals mx plus b formula and the formula for slope and whatnot. Okay, looking at the next problem. A certain apprentice has enrolled in 85 hours of training courses. The equation 10x plus 15y is equal to 85 represents this situation, where x is the number of on-site training courses and y is the number of online training courses. Okay. This apprentice has enrolled in. How many more hours does each online training course take than each on-site training course? So if this is the number of courses for each one, then we know that these are the hours each one takes respectively. So for number of online training, or for online training courses, it's going to take 15 hours. And for on-site training courses, it's going to take 10 hours. So 15 minus 10 is equal to 5, and it's saying exactly what we're solving for here. How many more hours does an online one take than an on-site one? And that's our answer of 5. It's really just understanding math in the context of the problem. Okay. I don't know how in the world that's a hard problem. This is like elementary level math, but we'll take it. Okay. In the given system of equations, a and b are constants. The graph of these equations in the xy plane intersect at point 4, comma, y. What is the value of a? Okay. So, this isn't your traditional system of equations. What we're going to do here is, since we know that both lines are going to intersect at this point over here, we can set them equal to each other after rearranging each one for y. So what I'm going to do here is, for the first one, I'm going to write our first step. Put in terms of y. And we're going to do that with this one. Ax plus by is equal to 72. So we have y is equal to negative a over bx plus 72 over b. That's our first one. And then we're going to do it for the second one too, which is 6x plus 2by, which is equal to 56. So we have y is equal to, this is going to be negative 6x, so negative 3 over bx plus, this is going to be 28 over b. Okay. And to make this a little more digestible, we're going to factor out a b. You know what? We're going to do that later. For now, we have both our y's, and we know that they're going to be equal to each other. The output's going to be equal to each other when x is equal to 4. So we're going to plug in x equals 4 and set these equal to each other. So we have negative a over bx plus 72 over b is equal to negative 3 over bx plus 28 over b. And right here, I'm not even going to rewrite it. I'm going to erase the x's right here and plug in a 4 for each one. But before we simplify anything, I want you guys to see that we can factor out a 1 over b. So we can take out a negative 1 over b, and this is going to be 4a plus or minus 72. And this is going to be a negative 1 over b factored out, and that's going to be 12 minus 28. I hope that makes sense. We're just doing algebra here, but we're factoring out a denominator of each number. So with that, we can cancel out each of these from the sides, and we have 4a minus 72 is equal to 12 minus 28. We're going to simplify this side here, and that's going to be 4a is equal to 12 minus 28 plus 72. 72 plus 12 is 84. 84 minus 28 is equal to 56. And we have a is equal to 14. And as we can see, that's answer D for this problem. I'm pretty sure this is the hardest one we've done on the channel so far. So really look at it step by step. The hardest part is definitely here, factoring out that negative 1 over b. You just kind of have to see it and figure, like, based off your judgment, what's going to be the fastest and most simple way to cancel out constants in my expression. Since we're not solving for b, we're solving for a. And yeah, I hope we're going to stop here for today, and I hope these problems helped. And please review the problems you got wrong if you did them before you watched my explanation, and work each problem step by step. Don't get ahead of yourself on these SAT problems. They're all relatively easy as long as you don't jump to conclusions. You do everything. You write out every little step, because as soon as you go wrong on one step, you got to redo the whole thing. It's a lot of time wasted. So thank you guys again for joining me, and I'll see you guys on day 18.